second question starts off by looking at things algebraically. So in 2a, it says determine the equation of the inverse algebraically. A reminder that algebraically, two things to do that. First, we're going to switch x and y, and then second, we're going to solve for y. What does that mean? Well, take where you had your y variable, you write your x variable. Where you have your x variable, you write your y variable. So now I have x equals negative y squared plus 4. And now I have to get the y by itself. Well, I have a y squared, so first I'm going to get that y squared by itself. I'm going to move the 4 over. And it's close to getting y squared by itself, but there's still a negative in front. So next I'm going to multiply both sides by a negative. Now I have the y squared by itself, and I can get y by itself by square rooting both sides. And we have to remember, when we square root both sides, we have the plus or minus. So this is finding the equation algebraically. You switch the x and the y, and then you solve for y. Next, it says sketch the graphs of negative x squared plus 4 and its inverse. So I'm going to do y equals negative x squared plus 4 on one graph, and I'm going to do it in blue. And I'm going to use my transformations. In my head, I have my x squared graph, my regular x squared graph ready. Can you see that this would be a vertical reflection, because it's outside the function, and then a vertical translation 4 units up. I want you to be able to see that parabola, flip it down, translate it 4 units up. And you see that it would have a vertex at 0, 4, over 1, down 1, over 1, down 3. It also have the point 2, 0, and negative 2, 0. And right beside it, in green, I'm going to graph plus or minus negative x minus 1. See if I've got the equation there? Negative x plus 1. Perfect. I'm going to graph plus or minus negative x plus 4. I'm going to use my original graph to graph my inverse graph. Because graphically, all we have to do is take the coordinates, switch the x and y coordinates, reflect over the diagonal line y equals x. So the point 0, 4 will be at 4, 0. 2, 0 will be at 0, 2, and negative 2, 0 will be at 0, negative 2, and what we get is a sideways parabola that looks like this. And something interesting happens is that when we look at the equation, can you actually see that a sideways parabola is actually 2 square root graphs put together? In fact, I'm going to just highlight the top of this one in purple. And beside the purple one, I'm going to write that this would be a square root graph that does not have a vertical reflection. It had a horizontal reflection, but not a vertical reflection. So as far as the plus or minus goes, this one would be positive in front of the square root. It had a horizontal reflection, So that means that there's a negative inside, and it's been moved 4 to the right. And because I have a horizontal reflection and a horizontal translation, I should write it in factored form. In fact, can you see that in the green equation, if I factored out a negative, I would get x minus 4. And this is a square root graph, flipped horizontally and moved 4 to the left. The bottom one here, which I'll just write in green, its equation would be negative square root negative x minus 4. It had a vertical reflection, a horizontal reflection, and then moved 4 to the right. And maybe you noticed this or maybe you didn't, but the square root graph is just half of a parabola. And the reason why the square root graph is always half of the parabola is because we want our calculators to function. If I drew the whole parabola, it doesn't pass the vertical line test, which would cause our calculators, every time we try to square root something, would cause it problems. It also explains why on your calculator, when you do the square root of 9, it only gives you positive 3. But when you think about x squared equals 9, there's two answers that are possible, positive 3 or negative 3. So you've learned in math to deal with that when you're solving x squared equals 9, you have to write the plus or minus. Because the square root function on your calculator to be a function only does the positive one. So it explains a little bit of that positive and negative that comes up with a square root. Did we answer, is the inverse a function? Same reason as before. Doesn't pass the vertical line test. It is not a function. In fact, it's two functions put together, the purple one and the green one, if we wanted to separate them. Okay, questions, circle 5 and 6.